Okay, so let's talk about sound event detection, because we're taking some ideas from that training approach here in this attempt to train a bird model. Because the audio data that we have a lot of different files per bird, and these have all been labeled, by people. Some people could be wrong. We know the majority of them are all going to be right. But whenever a computer is actually going and analyzing that audio, maybe it is the wrong class. So we have to take into account that our labels could be wrong, and also we have really long audio files. Like many of them are over 2 minutes, and so bird calls are just a couple of seconds. We have to figure out where in that audio file is that bird call, and we have to really throw out all the rest of the file that we don't care about. So how do we do this? One of the approaches that we're taking is first we're training a model with all of the audio files that we can, given the class, and kind of letting it just trains on that data, and then we go back through and we filter that data with that model. So for example, audio file 4, for class 2, we go and we train that when we're training the model. We use that as our training data. We don't pre-process it or anything. We just we cut decent sized spectrograms out of it, and use that to train the data, use that to train the model. Then we go back through and we reclassify that audio file with that model. Only in the cases where it fits, right? We're not going, at least in this approach, we're not going to reclassify that as another class and use that to actually train another class. We're just going to say if whenever we put it into the model, if it didn't come back out matching the class that it's supposed to, we're going to trash it. And then we're going to train another model with this filtered training data with smaller windows in the spectrogram, doing the same approach. Going through and training it with all the files that we can, all the data that we can, and then filtering that training data out and then training a third model with it. So we have multiple approaches, multiple iterations that we have to go through of creating our training data, training a model, filtering the training data, creating training data, training a model, and doing it again. So all along there are different places that we can improve this. And in most of these videos right now, I'm just using a basic model, not really putting much attention there, and we need to improve it later on. But right now it's kind of just proving that at the end of the third model, whenever we're classifying a segment of audio data and we go back and listen to it, that it actually is the bird that we're expecting it to be. So that's what we're trying to do here. It's just training multiple models, creating multiple sets of training data that's being filtered from previous models to create another model. And and also shrinking the spectrogram size down from a larger size to a smaller one as we're trying to really pinpoint where that sound event occurs. So that's what's going on here. That's what we're taking from the sound event detection and trying to get this all to work.